I'm Markus Konkol. I'm the Open Science Officer at ITC, which is the faculty for Geoinformation Science and Earth Observation at the University of Twente in the Netherlands. And today I would like to speak about the ITC Knowledge Hub. To admit that this title actually quite inaccurately describes what I want to talk about, because I actually want to talk about the development of the ITC Knowledge Hub. Because to be honest, the ITC Knowledge Hub does not yet exist yet. We're currently developing it. So today I speak a bit about the background, so why we think such a knowledge hub is needed. I will also speak about how we plan to develop the knowledge hub, and I will also tell you a bit about some first results of some studies that we carried out. Now let's start from the very beginning. What is actually the task of a researcher? So a researcher should produce new knowledge, I would say. So, but what is knowledge actually, and how does knowledge look like? I don't want to get too philosophical, and I also don't want to make it too complicated. So, because in science we also keep it rather simple. We just say, well, knowledge is described in a scientific article, which is usually a PDF document, including text, some figures, tables, and all that stuff. This results somehow in the very erroneous belief that someone publishing many PDF documents produces a lot of new knowledge. If we look at the definition of open science by the UNESCO, we see that scientific knowledge is not just a scientific article. Knowledge is also included in the research data, for example, also in software, in source code, and of course in open education resources. But if knowledge is also part of the data, the software and education, we should maybe rethink whether a PDF document is still, a PDF document alone is still the right medium to describe new knowledge. Maybe it's a good idea to think about some alternatives, and a knowledge hub can be such an alternative. And if we stick to this definition of open scientific knowledge, then a knowledge hub could be a place that not only offers a place for scientific publications, but also for data, software, source code, and educational materials. And since this is a definition of open science, these research components should be, of course, publicly available. If we speak about data and processes, we also need to talk about open science infrastructures, including repositories where we can deposit our research data, and computational infrastructures for our software and source code. And this aspect is also, of course, part of UNESCO's open science definition. Open science is more, so it's all about how of the scientific and also engage the public. So, for example, with the participatory and citizen science, and this can also help researchers to be more responsive to the needs of the society. And finally, open science is also about the dialogue with other knowledge holders and producers, for example, indigenous people. And there is already some kind of an open science evolution going on. So this figure shows the evolution of open science policies across funding programs of the European Commission. It starts in 2008 with an OpenX pilot. At that time, not much else was going on. In 2014, open research data and data management plans came into play. And in 2017, open data and data management plans were already formed, leaving some exceptions for restrict access to data, for example, personal information, sensitive data, and so on. And in 2021, under Horizon Europe, open science is already embedded throughout the Horizon Europe program. So apparently open science is getting more important, it gets more visibility. So more and more researchers are finally asked to follow open science principles. So they should publish code, they should publish data, and everything else that is needed to reproduce the results from the paper. Of course, we think that open science is good scientific practice. And open science can help to achieve some of the core scientific values, such as transparency, verifiability, and reusability. And if we achieve these, then we can create research that's more convincing and has more impact, which sounds pretty good, right? Unfortunately, there is a bit of a mismatch between theory and practice. Let's take reproducibility as an example. So publishing reproducible research is pretty hard because it is rarely checked during the review process, and also researchers do not get enough credit for it. So it feels a bit like we are publishing materials just for the sake of being open. And it's more like an annoying issue on the checklist. And it is questionable whether this results in transparent, verifiable, and reusable research materials. As I said earlier, in science we keep it simple. The message is publish many papers and we believe that you created a lot of new knowledge. And this is also how many researchers get evaluated. So why should they invest time and effort in preparing reproducible and reusable research materials, such as data and code? So while I totally agree that open science is good scientific practice, I don't think we are there yet. So we still need to find a way how open science can become good scientific practice. So why not developing a tool to assist researchers in adhering to open science principles? Ideally, this tool also helps reviewers and readers verify and use reproducible source code and data. But if we screen the landscape of supporting tools, then we will see pretty quickly that there are already quite a few tools that support reproducible research. And also, if I ask in our faculty and colleagues, then most of them are not at all familiar with these tools. So maybe some of them know a bit of Git, a bit of Docker, maybe Markdown, but it's almost it. And they are not only these tools, they are also even already knowledge hubs. So I'm not sure if you've heard of the group of Earth observation, in short GEO. They developed something that is called GEO Knowledge, which is basically a web application. What you hear is the starting page of GEO Knowledge. This is where you can search for research outputs. These research outputs can contain scientific publications, you can search for software, you can search for data, and you can also search for something that is called a knowledge package, to create something that is called a knowledge package. And this knowledge package contains the scientific article, the data, the source code, the software, and maybe also a running instance of software. By the way, the knowledge hub is not yet live, as far as I know. And this is how the GEO hub looks like. 1.5 years ago, I was hired at ITC to shape the idea of an ITC knowledge hub. So I'm wondering, what shall I do? Shall I just install some of the tools and offer them to the researchers at ITC, at our faculty? Or maybe I should just copy the knowledge hub and say, well, here it is, here you go, use it. This is certainly an option, but this is pretty much top-down. And we will have something later for discussion, and I would be happy to hear your thoughts about it. I decided at the end to follow more of a bottom-up approach, and this should look as follows. Of course, we also have some kind of an idea ITC knowledge hub look like. I took this simplified description of the research cycle and added some options to make each step more open. And the idea is that ITC knowledge hub supports each of these steps. I would like to highlight just a few. For example, the ITC knowledge hub can support researchers adhering to open data and open source software principles. It can also inform about how to store data. It follows the fair, care, and trust principles. You remember the open science definition that I showed at the beginning. So scientific knowledge is not just a scientific article. It's also the data and the software. And that is why in the ITC knowledge hub, we want to speak about a research compendium that contains all the materials needed to reproduce the results. So the scientific article, the data, and the source code, software, also the computational environment, also metadata. And of course, whatever is needed to make qualitative research more transparent. So at our faculty, there are not only quantitative researchers, but also people who are working with qualitative data. So the concept of a research compendium is pretty similar to the one of the knowledge package that was part of the GEO Knowledge Hub. So if we think about a knowledge hub or some reproducibility tools to support reproducible research, then we mostly think about technical tools, but we might also consider services. So before submitting the research compendium to a journal, the authors can request code check, which is a process for independent portion of computations underlying research. And the overall question underlying a code check is, was the code reproducible once for someone else? Not only for the author, but also for the code checker. It's a very simple process. The first step, the author of a scientific article and the author of the analysis provides the code checker with access to code and the underlying results in the manuscript. In the second step, the code checker tries to reproduce the analysis, to execute the analysis on the own machine. And the code checker checks if the code works, if it generates the expected output, so figures, tables, and so on. In 3, the code checker creates a certificate, including how the code was executed, was checked, and also some recommendations to improve code. And finally, in step 4, code checker publishes the certificate on Zenodo and creates a badge for GitHub repository of the author of the article and the analysis. And this is what author can also cite in the scientific article to show that the author cares for reproducibility. That's how it looks like. On the left, you can see the certificate, and on the right, the mention in the supplementary material section in the paper. So here, the authors mention that the code check was carried out, and they also added a link to the certificate. Coming back to our users of ITC Knowledge Hub. So as I mentioned, we want to have some kind of a bottom-up approach. I'm currently in the process to organize several focus group sessions to share the ITC Knowledge Hub. In total, I'm planning to organize at least 6 sessions. And 3 sessions were carried out already. And I started each session with an introduction that's very similar to the presentation that I'm currently giving. And we try to work on the following questions. So first of all, under which circumstances would you, as a researcher, contribute to the ITC Knowledge Hub? So what would motivate them to contribute to the ITC Knowledge Hub? The second question is, how can they contribute to the ITC Knowledge Hub? So how can they include their research materials in the ITC Knowledge Hub? The third question is, which needs should ITC Knowledge Hub address? Or maybe they need some kind of teaching materials, maybe guidelines, reusable templates, and so on. And finally, which problems should the ITC Knowledge Hub solve? So what kind of problems in the context of open science do researchers at ITC currently have? So if we think about data sharing, code sharing, collaborative working, infrastructure, and all that stuff. Oh, and finally, the last one, which benefits should the ITC Knowledge Hub have? So when would the researchers at ITC say, okay, if this feature is included, I will definitely go for the ITC Knowledge Hub. So the overall question of these, the overall goal of these questions was to shape the ITC Knowledge Hub. And I wanted to give it a bit more of a structure. And this is why I asked participants to split into smaller groups and develop user stories, which is quite a common tool in software development. User stories can be a helpful tool to define the needs and the requirements from the perspective of the users. And the approach is very popular in software development, since it is quite useful during the design stage of a product, particularly when it comes to software. The best thing about user stories is they are very simple, since they are only composed of 3 components. A user story describes who needs what and why. And these are the mandatory elements. But user stories can also contain information about the when. For example, a specific stage of the research cycle, or the where, for example, in class, on a conference, a presentation, and so on. This information is rather optional. And each user story has the following form. SA, followed by the type of the user or the role. I want to is followed by the feature or capability that is needed. So that is followed by the need, problem, or benefit to be solved. So we have the who, the what, and the why. As I said, I conducted 3 sessions already. One was even an in-person session, and the other 2 were online. I would like to show you some very initial results. This is just a very first impression, a first screening of the user stories. So first of all, guidelines are quite an often mentioned issue. For example, one participant stated, promote I would like to have guidelines on what steps my PhD students should follow to document their research in an efficient manner. I also saw several user stories that describe some technical stuff, such as searching for materials, reusing materials. These features actually exist already in some of the tools that I presented before. So maybe it's more about raising awareness for these tools, improving them, particularly by increasing the findability and reusability of research materials. So instead, one participant did not ask for additional tools or new tools, rather he or she asked to link the ITC Knowledge Hub with existing platforms. So Dance Easy is, for example, a research data repository at the University of Twente. Canvas is a teaching tool, and Pure is a tool for hosting scientific articles. So I think how I interpret this statement is that they don't want to have yet another tool where they should deposit the data, the code, and the paper. It's more about linking existing tools. And yeah, this also speaks, as I said, against developing yet another tool. Several user stories also refer to rewards and recognition. So one participant said that as a researcher, I want to receive a certificate for my contribution so that others can refer to my contribution and that I can use it as evidence in my narrative-based assessment. I encountered a bit of resistance against open science. So one participant stated, as ITC staff member, I feel open science is part of my job, not something additional. So I don't think it's free time. It's a free time activity or increase of workload. So this is something that I encounter pretty often when I talk to researchers. They see open science as an additional work. It's not part of their daily work. And this is something that's also strongly connected to the rewards and recognition system. Finally, reusability plays also an essential role in teaching. So one lecturer apparently said that as a teacher, I want to access old existing lecture materials so that I can reproduce, build a new teaching material, lecture or course. I also would like to share some further experiences I made. So, for example, some participants had some difficulties to write down user stories. But on the positive side, they required a few discussions. So maybe this is also a good side effect of these group discussions, that they think about open science, they discuss, this raises awareness, and this maybe sets a seed in their mind. Many also struggle to stick to the user story template. So some people, I saw many user stories that were just incomplete. They described what kind of functionality they wanted, not why they are needed, from which role. Sometimes it was difficult to get people engaged. So as you know, we have Corona for quite a while already. We are used to online meetings, but at the same time, we are also pretty tired of online meetings. As I said, there's also a bit of resistance to open science and some concerns, and many researchers are also simply overloaded. So if I ask them to do something additional like open science, then yeah, it's a bit difficult to get that managed. And finally, also there's still a bit of a blank page. So we are still at the very beginning, which is good because we can create something completely new, but all beginnings are also difficult. So what is happening next? I first need to carry out the remaining 3 focus group sessions, and then I will merge all the user stories into one document and try to analyze them in a qualitative approach. And based on the results, I will create some first mock-ups and also a software architecture. And this is what I will use and back to the users and ask for feedback. This is how the approach. And that was my final slide. So thanks for your attention, and I'm looking forward to some questions or comments.